Welcome to this explainer. Let's jump right in. Picture this. You're called to a scene. You walk in, check the fiber optic cable, it's totally intact. You test the signal, absolutely perfect. But then you glance at the computer screen and staring right back at you is that dreaded yellow warning triangle hovering over the network icon, zero internet access. As a field tech, you're going to face this exact scenario literally hundreds of times. The physical lines, perfect, but the user is still completely cut off. Today, we're going to crack this mystery.
So, if the fiber's fine and the signal's perfect, why is there no internet? Well, here's the secret. The physical cables, they're just the alibi. The real culprit is almost always hiding in the digital language of your network, specifically in a protocol called DHCP. This is the whole system responsible for handing out digital addresses to your devices. And when it fails, your device is basically invisible. It can't talk to anyone. So let's put on our detective hats and examine the four main suspects behind a DHCP failure. Here's our lineup for today. We've got Suspect 1, the silent suspect, Suspect 2, the desperate code, Suspect 3, the imposter, and Suspect 4, the identity clash. Then we'll wrap the whole thing up with the golden rule to fix them all.
All right, starting with our first gray-coded mystery. Suspect 1, the silent suspect, or the missing IP.
The symptom here is super obvious. Your device is physically plugged in or connected to Wi-Fi, but crickets. Completely silent. If you run an IP config check, that IP address field is just totally blank, or maybe it's endlessly stuck on acquiring network address. It has no voice. Now, as a technician, this is your cue to immediately stop checking the cables. The issue is digital. You're looking at three main culprits here. 1, the main router is just frozen or turned off. 2, the DHCP pool, basically the router's inventory of addresses, is 100% full. It's run dry, nothing left to rent out. Or 3, the network's MAC filtering security is actively blocking that specific device.
Once you've ruled out a blank IP, you might run into our next yellow-coded suspect, Suspect 2, the desperate code, officially known as APIPA.
Honestly, this might be the single most important code you ever learn in the field. You check the device, and instead of a blank space, you see an IP address starting with 169.254. What is that? That's APIPA, an automatic private IP address. Microsoft actually introduced this way back in Windows 98. It's basically a desperate secret code the machine creates for itself. It's like the computer is screaming, hey, I need an address over here, but it's getting zero response from the router. So in a total panic, it assigns itself this 169.254 emergency number. But the tragedy, this leaves the device completely isolated. It can't reach the internet at all. It can literally only talk to other lost devices sitting on that exact same local switch. So, your reaction here is absolutely crucial. When you see 169.254 on that screen, your field action is clear. Stop checking the PC. Seriously, walk away from the client's computer. It's doing exactly what it's programmed to do when it's abandoned. You need to head straight to the main router. Verify if the DHCP service is actually running, because right now, it's completely ignoring cries for help. Let's move on to our blue-coded mystery. Suspect 3, the imposter. Now, this one is incredibly tricky. In this scenario, the device actually gets an IP address. Success, right? Wrong, because it belongs to a totally alien network family. Look at the expected company network. It's supposed to be 192.168.1.something. But instead, the device is holding on to this weird alien address like 10.0.0.5. Its gateway is pointing to a ghost. It's trying to send internet traffic to a door that literally does not exist on your network, which means a total loss of internet. Which brings up the obvious question, who on earth handed out that alien address? The official telecom router definitely didn't do it. No, the true identity of this imposter is usually a rogue DHCP server hiding somewhere on the network. Out in the field, this is almost always a misconfigured Wi-Fi extender, or maybe an old secondary router that some employee just plugged into the wall by mistake. That rogue device goes rogue. It starts aggressively handing out its own bad IP addresses, hijacking your devices and just pulling them into the void. To fix it, find the imposter, unplug the thing, and the network will heal itself. And that brings us to our final red-coded suspect. Suspect 4, the identity clash, or as it's more commonly known, an IP conflict. This is essentially a violent digital clash. Two devices fighting to the death over a single identity. Take a look here. We've got device A, a smartphone, asking for an automatic address, and device B, a network printer. Because, let's be honest, it's always a printer, right?
Someone went into the printer's settings and manually assigned it a static IP of 192.168.1.20. The disaster happens because that number, 20, is sitting squarely inside the router's automatic DHCP pool. The router has no idea the printer claimed that identity manually, so when the smartphone connects, the router hands it that exact same number.
The symptom of this is immediate and, frankly, super frustrating for the user. It causes violent instability. You're going to see pop-up alerts screaming about an IP conflict. The internet connection for both devices will drop, reconnect, and drop again every few seconds. They are literally ripping that digital identity away from each other over and over. It is pure digital chaos.
But hey, don't worry. As a digital detective, you have the ultimate preventative weapon against this. It's how we ensure these four suspects never disrupt a network again. We call it the Golden Rule, smart organization. Here are your exact tactical steps to fix an identity clash and bulletproof the network. First up, disconnect the warring devices, just to stop the immediate conflict. Second, switch them back to automatic DHCP so they can grab fresh, clean addresses from the router. And third, this is absolutely critical. If you really must have a static IP, maybe for a printer or security camera, you have to ensure the number you assign is strictly 100% outside the router's automatic DHCP pool.
To put that into perspective, let's use a concrete example. The number 10. If your main router's automatic pool is set up to start leasing addresses at number 10, that means everything from 10 all the way to 254 is completely off limits for manual assignment. If you need a static IP, you have to pick a number below 10. Like 2 or 5 or 8. By keeping your manual IPs totally out of the automatic pool's territory, an identity clash literally becomes mathematically impossible. I really want you to remember this absolute truth of field diagnostics. With smart organization, the faults end. It's really that simple. When you take the time to understand the digital language of the network, when you correctly configure those automatic pools and banish rogue devices, logical organization is going to defeat digital chaos every single time. The physical cables? They're just the roads. It's the DHCP traffic signals that actually get the data home.
We've covered a ton of ground in this explainer today. You now know how to spot the silent suspect, how to decode that desperate 169254 API-PA code, how to hunt down alien imposters, and exactly how to stop violent identity clashes. You've officially mastered the digital clues of DHCP. But before you close this case, ask yourself, okay, you've conquered the router, but what other logical ghosts are hiding right now in the switches and firewalls of your physical networks, just waiting for a digital detective to decode them? Think about it. Keep exploring, keep learning, and I'll catch you on the next explainer.